Hello and welcome to second lecture in fourth chapter in comprehensive course on machine learning, data science and artificial intelligence. Now we want to learn about this topic, introduction to Numpy library. And as I already said, this is just a basic discussion. In next chapter, some more advanced usage will be discussed. First, what are libraries? Now, many people think that whenever I write some code, for example, let me give one example to you that I write a code like this. Say L1 equals 1, 2, 3 and L2 equals 2, 5, 6 and I then write L3 equals L1 plus L2 and I press enter. Control enter for Jupyter notebook. No output because I have not written L3, but if I write L3, then this is the output. So this is the usage of pure Python. Here no library is involved, nothing, and this behavior is the behavior of Python, where this plus operator does what? It does the concatenation of two arrays, 1, 2, 3 and 2, 5, 6. Okay, and therefore a single array is only obtained, and or a single list is obtained, rather concatenation of two lists. Okay, and a single list is obtained which has elements of first list followed by elements of second list. Now, if I want that behavior, that the corresponding elements should be added, so that means the new list should be, suppose I want this behavior, that L3 equals a new list which is also of 3 members and which is the sum of the members. Each member is the sum of. Now you cannot get this behavior directly. Of course, in last chapter we did it that you have to develop a class vector and then you have to do operator overloading and plus operator can be overloaded. But will we write that long code every time? You can refer to the previous chapter and you will see that it requires at least 7 to 8 lines of code to get this kind of behavior, where I get 1 plus 2, 3, 2 plus 5, 7 and 3 plus 6, 9. I cannot get directly. But every time I would not like that. So the job is made easier by some people who have already written that code and put them in a library. So that library contains that code, and not only that code but many similar codes for several very complex operations. So that library, if I import and when I write this import numpy as np, it looks a single statement, but actually you are importing several different pieces of code, and this library is nothing but, so I am just trying to explain what is library. Library is nothing but a collection of code which provides some desired functionalities. Okay, and now if I write this way, that if I convert into numpy array, and similarly the lower one also, I convert into numpy array, and I now write L1 plus L2 and everything, then you will see unmatched. Okay, sorry. Now I get the desired behavior. Okay, so that means just by importing one library, I have avoided 7 to 8 lines of code. Okay, and not only that, one example of vector addition, but I can do several different things. So many things that every time you don't require to write class and definition and then write multiple lines of code. Instead, we have decided that all the mathematical calculation should be included in the code related to that should be included in this one library. So these are various libraries for different purposes. Pandas is best for data manipulation. What is the meaning of data manipulation? We are going to see later on. Numpy is best for mathematical operation. We are going to learn about Numpy in this chapter. SciPy is also for calculation only, but for scientific calculation. Say you want answer in that kind of format, 2.5 into e to the power minus 45 or 47 exponential minus 10, like that. So SciPy library is for that kind of scientific calculation. For example, if you want to write definition of a mole, then you have to write 6.02 multiplied by 10 to the power 23. Now that is written this way, but when we write it, but if you want to use it for calculation, then you have to provide a scientific version of this mole number. Okay, 1 mole is equal to how many atoms. So at that time you require SciPy type library and it can perform very complex scientific calculation and astronomy and many other fields, physics. They require this library. Scrappy is, as its name indicates, it is used for web scraping. Web scraping is an art by which one can scrap data from any website of which is on internet. Of course, there are certain laws of every country, and there is one ethical way of doing scrapping and another unethical way of doing scrapping. So we learn about scrapping, but we will stick to the ethical way of doing scrapping only. Okay, Matplotlib and Seaborn, these are visualization libraries. Okay, scikit-learn is an all-rounder, all-in-one library. That means later on, as we become advanced in our course, somewhere after maybe 12th or maybe 15th chapter, almost entire course thereafter will be based on scikit-learn, because a single library can do everything. Of course, pandas, numpy are required, matplotlib is also required, and seaborn is also required. But this scikit-learn will handle all the necessary advanced function related to the data science. Okay. Then TensorFlow. Now TensorFlow is required. It is a good substitute for scikit-learn, but it has one big advantage, that it can use the GPU, graphical processing unit. Nowadays, deep learning and artificial intelligence are becoming very popular. So these GPUs of NVIDIA or AMD, they are always they require specialized libraries, because they do not do calculation like normal calculation. They first convert everything into tensors, and then they do the calculation, and then finally they convert that to the answer which is legible or understandable by us. Okay, and the advantage with GPU is that some data science models, their training takes hours. When I did not have a powerful system with GPU, sometimes I used to keep my laptop on for entire night, or even I have kept it on for 24 hours or 36 hours sometimes for training a very complex model or based on big data. And then once the model is trained, I can use it. But with GPU, the same training which requires say 24 hours can be finished within maybe around half an hour. Okay, so it is tremendously fast calculation, and scikit-learn cannot work with GPU, but TensorFlow will work with GPU. Okay, this scikit image is actually a part or related with scikit-learn, and it is also image processing library, just like Matplotlib or Seaborn. But these two are for creating image graphs, while this is for processing image. That if you want to manipulate an image, and LibRosa is a special library. It is used for actually audio manipulation. Okay, and you should not understand that this is a very some niche application and we are not using that in our daily life. You are using that in everyday life. For example, your Apple Siri or your Cortana or any digital assistant in the Google also. You can just speak your instruction and it understands. But actually speaking, computer understands only binary language. So 0, 1, 0, 1, 0, 0, 0, 1, 1, 1, that kind of signals. So the question is how this whole magic is being done, where you are converting your audio signals into 0, 1 binary signals. Computer processes that because it understands only binary, and then it presents the answer back in audio form. So your Siri answers you in audio form or speech form. So that speech recognition and audio manipulation, music industry, then audiologists in EMT medicine, they are also using this LibRosa library. Okay. Now, what is the best way? This I explain how libraries are helpful. Okay. Now, what is the best way to learn about this library? Now, this is a very, very important, simple instruction. Please keep this in mind throughout the course. That still today, in the age of AI, if you want to go in depth of any library, then just Google or in your ChatGPT also, just write that explain me with the help of example of official pandas library or official numpy libraries. Here for your convenience, I have given the hyperlinks of all official websites for these all libraries. Okay. For example, for pandas, I click it and you can see I am taken to this where how to install pandas and how to use the panda user guide, all examples. It is how to use it with Excel and how to use it with HDF5 data form. That is used for big data. How to use for Paraclete data form. That is also Paraclete data form. That is also used for big data. And how to use with Google's BigQuery. Endless information. So whenever you are stuck anywhere that okay, I am handling Google BigQuery in my job and my boss has asked me to use pandas, but I don't know how the two together work. Then just follow the official documentation and you will be fine. Then this NumPy library. This is the official documentation of NumPy. And latest documentation, if you see, this is here, absolute beginner's guide and the user's guide, depending upon where you consider yourself. Suppose absolute beginner's guide, and it starts with almost most basic type of examples. And no course can teach you all the examples and all the features of any library, even a single library. All the features are impossible to be taught by single course, because it will take hours and hours to study one library. But these documentation are not like some course material which are to be mugged up. They are called reference documents. So throughout your life, wherever you are stuck, you can use them. I will show matplotlib, not all, but sorry, matplotlib, yeah, here, because it is a really nice visuals you can see. It is a visualization producing library, and starting from very simple visualization like this to slowly complex visualization, bubble chart, and multicolor visualization, this kind of chart, and so many different things. And everything on this website, everything is free. You don't have to spend a single penny to learn this. They also provide such cheat sheets, and cheat sheets are nothing but after some time you will find it difficult to remember everything, so you can keep this kind of thing handy, maybe paste it near your work station, and you can write the code that this is how basically the library is to be used. Nobody expects that you remember each and every feature of any library. Okay, I will be providing several such cheat sheets. In fact, I will be providing. I would say that looks like an exaggerated claim, but I will be providing almost every cheat sheet which is available on internet to those people who have enrolled for these course. Then this scikit image I'm not showing, just librosa. Okay, because that librosa is special, as I said. It is used for speech recognition, and it is used for music manipulation. So these are tutorials. They actually teach you how to install, and starting from that, how to write code and everything. And now you have your favorite AI assistants, so you will not worry. Okay. So this was a general discussion about what is a library and what are possible libraries and how to find authentic information about any library quickly. Next, we will start about Numpy. Okay. So in Numpy, why this diagram is kept again? Because if I see the uses of Numpy, arithmetic operations, statistical operations, bitwise operations, copying and viewing arrays, stacking, matrix operations, linear algebra, broadcasting, mathematical, searching and sorting and counting. Now, what is this? That is all this blue thing. Okay. So initially, mathematics is required for every data science process, and this Numpy makes it easy for us by embedding, hiding the implementation details inside, and you just have to write some simple code, but inside all the mathematical operations are automatically done. So you don't have to be a math wizard to look like a math wizard. That is the greatness of this Numpy. Okay, we will start with Numpy in from here in next lecture. Thank you.